So I'm going to try to fix the leaks that I'm getting on the Hellas code. And I assume that the reason why it's happening is because the strategy that I'm implementing now, which is the simplest way that I can think about right now, which is just to replace the old node with a new one. But I have no idea how to solve this. Like why is the leak happening when it finishes executing? I'm not 100% sure if it is that big of a deal either way, because this code here is never gonna be run on the application. It's just running to build the scene from the code, and then after that you're just gonna run the normal code. So it's probably not gonna leak the resources when it runs normally. It's just when I'm building the scene, but obviously it's better if it doesn't leak. If I spend a bunch of time trying to figure this out and I can't find a way, then I'm probably gonna think about a different strategy to do what I'm trying to do. And I wrote down here like the ones that I thought about so far. I might think about a lot of them more, which is basically the problem is what I said on the previous stream, I think, where it's becoming a lot more clear on my mind, but the fundamental key of the issue is that you have two different scene states, and you need to synchronize both. Because one is being developed from the code, the other is from the code and the editor. Then every time because the code is static, every time I run the code, it has to take into consideration the newest states of the tree. And the way that I was initially thinking, and I'm still thinking about now, is that I'm getting the tree state from the sync file, which is the latest, is a file that contains the latest changes that were made to the scene. And then the code is designed with the latest state in mind. So the code has to take into consideration the latest states. But I also thought about that it might be easier to think about, like, to do completely two different scene files. And one is the scene file that is the result of the code. The other one would be the actual scene file. So I would do everything from code separately, and then I would create algorithms that merge the two. But then I realized that it's probably the same thing, because at the end of the day, you're still gonna have to traverse the tree and then compare the nodes in some way to see like if any changes were made or stuff like that. And also the meta programming is very similar to the problem of versioning from the GitHub solves, or the Git solves from code. So like you have multiple different branches, and then you're trying to synchronize everything into the main branch. So I think it's a similar thing. So if I went that route, it would probably be too hard, which is this way here. So I think that this is probably the easiest way, which is just you get the root node from the sync file, then you change the root node based on the code, and you just check to see if the tree has a name that you're adding. If it does have the name, then it means that the node already exists, so you don't need to add it again. And then you have to replace, because you want the state that matters to be the one that you are setting from the code, because otherwise you would only be able to set the state once, and this is not very good. So for example, let's say I want to change the position here. Obviously I want to change, I want the last position that I put there to be the one that counts. So the node on the actual scene has to be replaced when I add as a child. And I found this function that they have, but for some reason, it seems that it is leaking resources, is replaced by. So here I'm getting the name of the class, and I'm making the name based on a global static hash map. that is gonna map the name of the class, or is gonna map the type of the class with an integer. So that way, every time you create a new instance of a class, it creates a unique name for that instance. Then I check to see if the hash set, which is the one that I update in the beginning, contains that name. If it contains that, it means that the scene already has that node. Then what I'm thinking about doing is just replacing. So the scene root is the root of the scene. Then it finds the child with the name, gets a node. If the node exists, then here I was thinking about as well putting else and then adding this here. But it seems kind of weird because I can think about situation that the name would be on the hash set, but it wouldn't be on the scene. So maybe I should remove this one, and then but I think that this way is probably better. So I have just set before, have set the name of the child so that it is equal to the older one before, I think. This might be a problem as well, because if it's set, then they have the same name, which is bad. The problem is that if you replace and then you set, I'm not sure if it's gonna work. And this one I got from the loop here I got from other examples. They usually just mem delete the child, but I want to delete all the children from the old node. Because the old node is the one that is being replaced, and the child is going to contain all the new nodes. So I think the problem comes down to something related to the nodes that get created inside of the constructor of these classes. This is the issue, because they are going to be children of the class. And then each time you add a new node or you replace nodes, you need to remove all the children, I think, from that node. But then, like, this is a problem. Yeah, so this is actually a massive problem. Because if there are other children that are added outside of the constructor, then obviously you would add them again if you are creating from code. But if there is somewhere along the line there's a child that was added through the editor, you wouldn't want to delete. So what I can do is just create a function that takes that into consideration. So like checks to see if the name or if the value of the node is a node created from the editor or not. And if it is, then it's very complicated. I think the reason why it's leaking resources here is basically because of that. When I replace a node, because the Godot automatically deletes all the memory for the nodes that are parts of the scene tree. So it's something happening, I think, with the nodes that get replaced. But it's kind of weird because I am deleting the node and the children with the recursive function. So I don't know what's going on. Which makes me want to create a different strategy exactly because of this. Because it seems like if I could find another strategy that just bypasses all of this stuff and also is gonna make it easier to take into account nodes added from the editor and stuff like that, then probably it might be a lot better, because then I don't have to think about these kinds of things. I was thinking about like the potential ways would be to, I think thinking about it as separate things make it a lot easier to reason about this. So like viewing the tree built from the code completely separate from the tree built from the editor. I think this is probably the better approach to find a solution that is simpler. So like I separate the two things in my mind, but I'm not sure if that makes any sense. The way that I was thinking about it is like you think from the perspective of the code as its own tree, and then you think from the perspective of the other scene as entry points created That way, the logic that I create from the code there would be some means I wouldn't even need to get the state before from the sync file. I would just create like components based on composition approach, where instead of the function, I'm connecting different nodes together to make up components. And then I would just view the editor as like the function would work as an input and output, where the input is the entry point on the main tree that the new component is going to be placed at. And that way it doesn't matter, because then I can do the traversal of the tree in the beginning. So the flow would be like traverse the tree based on whatever logic I want. So probably filter the tree for the name that I want to put to replace the elements from the code. Then create the tree completely from code of the elements that I want to create. Then place them there. And the problem is, obviously, if you have like a component that you want to merge editor nodes with code nodes, then it wouldn't work. But I think that's just a limitation. But there's nothing you can do, because it's a case-by-case basis. So you would break down naturally anyway, in which case all you would do is just break down the function with more functions. So you would have two entry points. So like, for example, let's say you have a tree. One level have nodes created from code, and another level have nodes created from the editor. And then from code again. What you would do is just create a smaller component from code, place into a part of the tree that's created from the editor. Then go on the editor, create other nodes as children, and then run another algorithm to filter again and complete the whole element from code again. And I think there isn't like a way to programmatically do it, because on the editor it's going to be manual doing it. So I think that might be, but then if you think, I went through this chain of thought, but then what I thought about is that, like, what is the difference between thinking about it in this way and thinking about it as the entry point of the roots? But I do think there might be a difference, because thinking the first way that I talked about, it seems a lot simpler. So that might be the way to go about it. Because it's more about the way you think of the structures that determine how usually the function can be the point of the function. Like the way that it's working here is that each project is going to have its entry point function, which is this one. And then here is going to have the control flow that determines the entry point for each sync, depending on the project. So the structure of this function here is going to depend on how I think about the nodes. I guess the question comes down to, I was thinking about the entry points, and what is the difference between having the two and three? Then where should they stay? They're gonna end up being the same problem. It's easier to think about the first scenario, because then you can separate the tree created from the code from the tree created from the editor. But eventually, it's going to end up going to the same direction, where you're going to create the entire tree from the code, and then you're going to traverse the tree to find the entry point nodes where you want to put the components. But then eventually, you might want to add another tree created from the code somewhere as a child of the previous one that you created, or you want to add editor nodes as children of the one you created from code. And if you do that, then on the traversal of the tree, you would need to check to see like what is the state of the children at a certain point. And then you would fall into the same problem, where every time you run the code, you would need to replace the node and all its children, so that you don't have a situation where every time you run the code, you're putting like extra nodes that are repeated. The issue is that like the scale of the tree state, the tree state scales infinitely. That's a problem. Like there can be an infinite amount of structures for certain roots of the subtree, for example, that would determine the structure of the tree. And like if you have a mixed tree, you can't replace the whole tree. You have to replace a node and keep the connections. But then the problem is that you have to replace certain children, because those children are perceived to be in conjunction, let's say, with the node. So like what I'm saying is that like for certain nodes that I add from codes, I'm definitely gonna have other nodes that I add as children of those nodes on the constructor. So conceptually it makes sense to think about these children here as parts of the component. But there can be an infinite amount of structures that you do inside of a constructor that conceptually you think about it as being part of that node. That would make it very hard to figure out how to replace. So the easiest way would be to create a distinction from nodes created from inside of the constructor of other nodes, and nodes created added as children outside of the constructor. Because if you flag all the nodes that are added inside of the constructor as parts of being, I think they have something related to this with groups. That's why they did have the groups. So maybe that's the way to solve this, because that way, like you would create a recursive function that replaces all the nodes, or that views all the nodes that are added. Yeah, but then it seems very complicated. Because you need, essentially what you need to do is slice a tree, take all the components that are part of the subtree, share the nodes, like the main node and the other nodes added as children of this node, and then replace with the other components. And keep all the other nodes in the same way, like with the same structure. And that's very hard to do. And even, like, I have to think about this, because even if I solve for the leaks here, this is still the simplest case possible, because I'm adding the nodes directly on the scene root. And there is no merging of states from the nodes that I'm adding there and from the nodes that I add from the editor. So it's going to become a problem when you have this node that you created from here, and in the editor is not going to show the children that are added inside of the constructor. It only shows the node. For example, if I add a physics slider on the editor, it doesn't show these children here. it's just gonna show the physics slider. So if I add if I go from the editor and I add a child to the physics slider, then it's gonna show on the editor. But from the engine's point of view, they're all children of the physics slider, regardless of whether or not they were added through the editor or through code. And when I replace, that's where the problem is, because then, like, how do you free the memory for, how do you decide which nodes should remove and which nodes should not remove from the subtree that the node that is going to be replaced is? And that's why I'm like thinking there must be a way, I think, you should think about this in a compartmentalized way, where you make the distinction where from the code you want to concern yourself with the state of the tree that is created from code, and then you merge them after. I think there must be something like that, I think. And I think the key is like figuring out the boundaries. The key is the entry points, I think. So maybe going in this direction is probably better, I think, than trying to figure this out. Because it's going to be a lot easier to think about it. So I'm thinking about like separating two different stages. So like I have a selection of 3 traversals. It's kind of like, it's very similar to diffing. After I use ChatGPT and Perplexity to think about the problem, and like this synchronization and diffing is the same mechanism that React works, for example. So as far as I understand, the way that React works is that you have the virtual DOM and you have the actual DOM. And it's the same principle of double buffering from, I think OpenGL uses, where you work on the virtual DOM until the virtual DOM is ready, and then you swap the virtual with the real. So that way the changes seem instantaneous, but they're being done behind the scenes on a fake tree, let's say, where the updates are being made. And what React does is it has something called a fiber, and the fiber is just kind of like a worker that traverses the tree and checks for state updates. And then based on whether or not based on this diffing algorithm, which checks whether the node is the same or not, it performs the updates. And it's very similar here. So like in this case, I'm thinking about separating where I have one part of the thing would be the tree traversal, as like a worker. A worker that traverses the tree and finds entry points. But this is the issue, because eventually it's going to get into a situation where... Yeah, but I think it doesn't matter, actually. Like a situation where I have a mixed tree, where like some entry points are on nodes that were created outside of the code. Because it's always going to be dependent on a case-by-case basis. So just compromise and do it manually. Because then the worst thing that happens is that but the problem is when you want to add a node on an entry point that already exists. But if that's the case, but then it would be the same thing, because I would have to update the host state. Either I have to update the host state or I remove the whole subtree. That's the problem. I think this is the key of the issue. I think this is the reason why it doesn't matter which way you go about it, because at the end of the day, it's going to be the same problem. And the problem is like... Yeah, so this is the issue. I was thinking about like instead of removing, you can just update based on the properties of the classes. So like create an algorithm that does the diffing. And maybe that's how it works on React as well. Like that's what the fiber does. Well, on a different way, obviously. So maybe this is the way. This is better. So instead of replacing the nodes, you just traverse the tree. So let's say, for example, I create a subtree from code, which is the one that I have there. And then I want to add that subtree on an entry point. In this case, it would be the sing root. But this is the second time that I'm running this. So the first time it added the nodes on the sing. Now the second time, I don't want to add them again, obviously, because then each time I run the code, it's just going to increase the tree. That's not the point. So what I have to do is figure out how to replace all the nodes that I'm adding here with the nodes that already exist on the tree without changing its structure. So it makes a lot more sense, I think, to update the properties of each node, because then you don't change the structure of the tree. You just change the state of whatever node you have there, I think. So instead of removing the nodes, because when you remove, you affect all the children in the structure. And I can't assume that I'm gonna have control over the names of the nodes that are added as part of the constructor of other nodes. Because then I'll have to change all the classes probably from Godot. That's the problem. So whenever you have a class where you're gonna add nodes as parts of the constructor, it's gonna have a node that they assign automatically in case there is no name for the node, and they have some logic for that. So those nodes, but I have to assume that those nodes are always gonna have the same name. I think that's always gonna be the case because of the way that it works there, but maybe not. Actually, I can see here, I can do the tasks and see. Because here, when you run with the verbose on the functions that do the cleanup, they put some messages there to show the name of the node and the IDs, I think. So I think it's probably always the same. 17, 124. Yeah, it's always the same, like the nodes created from the constructor. So let me think about this. I think that's what I'm gonna do. It seems much better. So instead of replacing the nodes, now let me close everything I have here. Instead of trying to fix the leak as well. It's basically this function. So on this part here, whenever the node has already exists, instead of replacing the nodes, I'm just gonna get this state. I'm gonna get the properties of the node, because the properties are the things that change. The functions are always gonna be the same. But maybe not actually. No, but if I change, that's the problem actually. So maybe I have to also check to see if there are new functions. No, but I think that doesn't make sense, because if you change the functions, then next time that you compile, even if the node already existed on the tree, is automatically going to change because of class DB. So the way you register the functions so that Godot and the editor understand, so that the engine and the editor understand, is with class DB on the bind methods function. And the state of the property is cached on the sync file based on that property macro. So I think that's the main thing. But the other problem, but I think that the other problem is easier. is when, like, whenever I can delete, no, but actually I can't delete because it's gonna influence. So I can create a variable inside of the HD manager, because the issue is that if you don't add the node to the tree, then it's not gonna automatically delete on the function that I created here, because this function, like, I have to manually delete these nodes because they are not part of the sync tree, the main sync tree that Godot has, because I'm not running the engine or anything like that. Like, it's a structure that I'm creating outside of the engine in the sync tree. So I'm responsible for deleting the memory for all the nodes. So I created this function here that is going to run for each root of each sync that traverses or that recursively deletes all the nodes for that root at the end when the HD manager runs the destructor. So what I have to do is manually delete all the nodes that I create. So the problem is that if you don't add the nodes there, then they're not going to automatically be deleted here whenever the name already exists. So obviously I can't delete them here as well, because then if there are other nodes that depend on that node from the main code here, they would break, it would crash, because obviously I deleted it inside of the function. So what I can do is just put them on a vector and then also delete them at the end there. So I think that's probably a better solution to try than to figure this out here. So what I can do is inside of here, I can get the node from the tree and then update the state. So here I would be I would put tree node. Then I create a function that receives both nodes, the new node and the old node, the new node and the tree node. Then I get the properties and I loop over them and I compare. That's probably better. So yeah, that's what I'm going to do. And I'm going to, the challenge on this one is how to know for sure that I'm going to, how to check if they are equal or not. The main thing that I'm not really sure is what happens with the nodes. It would be slightly inefficient, but it doesn't matter that much, because I would have to do it recursively for all the nodes that are child of the ones that I'm testing here, because the ones that I'm going to test are only the ones that I'm adding through code. So you would do extra checks for, obviously what I can do is put another value or see how the groups work for the nodes, and then always put the nodes that are created from code on a specific group, and then check whether or not the nodes exist on that group. So I guess I can do that later. So after I figure this out, I do this distinction. But even if I don't do it, then the only downside would be that it would check more times than necessary, because if you have a tree that has nodes added from the editor that are children of the ones that were added from the code, you would check the properties multiple times, depending on which nodes I'm trying to add here. So I have to make sure that I'm checking all the values. That's the problem. So regardless of, for this, I'm probably going to look into I have to think about what places do they get the properties. The obvious one is the save file, save scene. So on the save scene, I know that they loop over the properties and they use the get property list. And they get the state from property info. So I have to, probably on most classes they have copies, like they have the check. But for dictionaries, I have to see if the functionality inside of the class is deep copy or shallow. And if it isn't, I think I can just do it something recursively. But it might be very complicated because of variance. So this is the challenge, I think. How to make sure that I'm checking all the values to see if they are the same. That's probably better. Should do it like this. And then I do, each time that I test, I just do the function, I just call the function recursively for the children. So like in the beginning I check, so I put a base case where the node doesn't have, or the node is no. Then at the end, after you check all the properties, you call the function recursively, passing the children on a loop. So the same way that this would happen, so like here, check the quantity of the properties for both nodes, then loop over the children, call the function recursively. The base case would be when the node is no. And that would check the difference, select diffing. Then at outside of the function, here I would add the nodes to the vector, and I would free them after I do this. So let me think. I'm gonna just stop this. I have to search for the places where they get the properties, to see how they do it. I have to see maybe the inspector as well. So there's both the inspector and the scene file. So I have to think of, like, if there is a way, if there is a place where they do this comparison, then it's better, because I'm gonna be able to know how do they check for, to see if the properties are equal or not. So I'm gonna write down there like places where they do this, they potentially do this check. And this one, I think it's running out. So I'm gonna study this scene, the save scene first, I think. Or maybe you should run this again, because I have a breakpoint there. A resource saver. So I'm gonna run the debugger, and I'm gonna step over the save scene functionality. I'm pretty sure that I'm gonna put the name here already. So I'm gonna create the function is gonna be on the manager, and it's gonna be div properties probably. So yeah, should probably return an error, I think. So I'll be right back. I'm gonna think about what the function is gonna look like. Yeah, be right back. I'm thinking about whether or not should put an error on the function. I'm not really sure if it's necessary because there is no error, I think. Like if the check is done in the correct way, then it doesn't make sense, I think. Sure. Check for errors. What will happen here? I think I'm just gonna do voids and then I'll think about it later. And it's gonna be diff updates properties. This is the base case. Then here, I would copy this stuff here. And call for recursively. Well, that should be found our new nodes. And then in the middle, so here, as far as I remember, it's gonna be a list of property info. And then will be and then here you would loop in the way that they do there. So you call the functions here, I think gets property list. And you pass 3 nodes, 3 property lists. I don't remember if this was. I have to remember how or where is this defined. I think that's basically it. And then this is gonna use class DB to get the properties based on the object that called. This function declare on the macro that is going to check for the properties on the class hierarchy, I think, as well. And then this adds the property. So it creates a property, the type, metadata. Maybe I have to check on the setters and getters. So the key classes are class info. So have class info, method bind, and property info. So these classes, they allow you to serialize the classes on Godot because they are gonna translate, they're gonna store and translate the information. So class info stores information related to the class on class DB. Method bind stores information for the functions. So each function is a method bind. And property info stores for the properties. So what I'm thinking about is whether or not if I get the property infos, I'm gonna have the like all this information that is necessary to set. That's why I thought about the properties setters and getters, which are when you register a property on class B using add property macro, they're gonna create a method bind from the functions you subscribe there, which is based on the string names you put. So not sure if yeah, so here, based on the string you put here, it creates a method bind. So it finds the function for the class based on a function that they have, which is get method. Which they also use for the verbose here. So get method allows them to, you pass the string that is the name of the type of the class, and you pass the name of the function. And because the class info holds the state based on the subscription of the class, it's going to access what is the type of the class using the class info. So it's going to get the class info from the type of the class. Then on the class info, it stores a map of the names of the functions, which are the string names with how the function works, which is going to be based on a class that inherits from method bind. That class, it has on itself the call method, which is the method that is going to use the pointer that the function that is stores, that is the function, basically, the function pointer. When you use this bind method here, this pointer gets stored on a class that inherits from method bind. And then the moment you set the variable, it's going to call that pointer. It's going to call the function from that pointer using the call function from the method bind, from the class that inherits from method bind. And it knows based on the string because of the mapping that the class info stores. So, and these functions are available on class DB, I think. So I can call them from class DB. So I'm thinking about how to combine the two things, because I'm not really sure. So one way is to check first how they do it on the save scene functionality. And the other way is just go from the setters and getters. So I would use the same way that they use to get the function that gets the property, and call that function to get the property, and then compare depending on the type of the function. Depending on the type of the property, compare with the other one. So I loop over them, I get the properties of both of them. Then depending on what the type is for each one of them, I do some control flow that checks what is the type for both. Depending on what type it is, you do the check for that type. So I think I'm just gonna look for the scene file. I'll just release source. So this is gonna put the properties on the list here, and I think I'm just gonna always loop from the tree node. So the tree nodes I'm gonna be able to see on the, maybe the load is better. Check. I'm gonna spend some time on both of them, I think. The load and the save. But I'm gonna copy the way that they do the loop from the save, probably. I think on both of them they might compare, but maybe not. Or maybe it's more likely that they compare on the update tree from the inspector. The update tree maybe is a better place because the update tree is the one that is gonna set the but I think it doesn't compare, it's just gonna set. He's gonna get the setter for the property and then it's gonna call the setter for the new value. So the way that the inspector works is that each inspector is gonna have a GUI element and the GUI element is added inside of the update tree from the editor inspector. Then those classes that are equivalent to the GUI, the classes that create the GUI elements that are going to be responsible for each property are going to have inside of them member or they are all based on a base type. They inherit from the base type, which is editor property, I think, the base type. And that base type has a function called update property, which is a virtual function, I think, that all the GUI elements are going to inherit from. And those functions are going to determine, depending which kind of property it is, how it updates the value of the property. And then it's going to emit an event after it updates the value, which I think after the event is probably going to do something related to the other parts, to updates, like on the scene file or something. Actually, like, not really sure. Maybe it doesn't do that because it's only gonna change the scene file when you save. So maybe when you update the property, just changes the value of the class of the object using class DB. But it doesn't compare anything, I think. It's just configurations. This is the function that's going to create the GUI for the inspector. So all these classes are the classes that are responsible for creating the GUI elements that are going to allow you to update the properties. And all of them inherit from editor property. And then on the editor property, there is the update property, I think, function. And if the class implements that, it's going to, update property. Yeah, whatever. I think. Yeah, this is the loop here. So I have to see on here how they do this. So they get the name from the property, and then they use the get function on the object to get the property, which is the function that I just saw there, which is gonna check on the script, on the GD extension, and on the property, on the class CB for the property info, to use the getter from the property, if it has, to get the actual value, and the value is gonna be a variant. So I guess I can use the, I'm not really sure, the thing that I'm not sure about is these types here from the usage that they put, but I think this is more for differentiating how they're gonna cache on the sync file, because the properties are considered as sub-resources on the nodes. So depending on which kind of property it is, I'm pretty sure that they're gonna save it in different ways, obviously. So, but I think for my thing there, I probably don't need this, so I can just do the value like directly there, probably. Maybe I don't even need to check. Maybe it's just easier to assign the values. That way I skip the whole thing, because I know that's gonna be... It doesn't matter that much, because the headless code doesn't influence on the runtime of the thing. And I imagine that it doesn't matter, like, even in very big trees, it's probably not gonna take like hours, or like even like it's hard to imagine that it's gonna take like half an hour to update a massive tree. So like it would be like a micro optimization, because the purpose of running from the code is to update the properties. But let me think about this. Yeah, because even if I have a situation, yeah, but maybe this is like complicated. Because like the downside of this strategy is that it's gonna limit myself to always be forced to use the properties that I set on code instead of setting from the editor for the nodes that are added with the edit. Yeah, but actually it doesn't matter that much, because the nodes added from the, I can also just change the name as well. Yeah, but then it becomes a problem, because if I change the name, it's gonna change the structure of the tree. So like the downside is that for all the nodes that I create from the codes, I'm not gonna be able to edit them, the properties from the editor, and keep it that way, because then the next time that I run, then it's gonna take the one that I added from the code. But I think for like after I solve this stuff, then if I'm able to solve it this way, I can just put another check there. Like I can put more information on one of these classes, and then based on that information, I create a distinction. Like I can change the object class, for example, so that it has a Boolean variable that's, if I set to true, then it doesn't change anymore the properties based on the loop that I put there. So I think it's not that difficult to, like, and it's not that big of a deal. So I'm not, probably just do the simplest. Maybe, yeah, that's like what I said there. Maybe I don't need to compare. So I would just get both. I would just get the value. I have to check if they are the same though. But I think that if you use... So maybe I would check outside of the function, I think. So I need to check... So before I run this function, I think I need to check the types of the nodes here. If they are not the same, then I throw an error. Because that's like a situation where you have nodes that have the same name, but for whatever reason they have different types. But if they have the same type, then I think that it doesn't matter. Like the order is always going to be the same because they're using the same function to get the. Or maybe not, because it's possible that you add the GD script on one of the nodes, I think. And that would make it so that they're different. But I can check based on the name of the property. So I get both properties from the name. This like this is the problem. How I'm gonna get here? Unless I do a nested loop, which is not very good. So I have to see if I can find a way to loop over them. I'm gonna ask ChatGPT probably how to loop based on the index instead. I guess I can do a normal for loop maybe, and then just do based on the index I select. I'm gonna ask ChatGPT. And this is what I was thinking. Get size. Yeah, this is probably already like everything you need to do. So I think that this should work probably. So get the two property infos, then you compare them, get the values, then if they're different, use sets. If this is correct, but I'm pretty sure that it is. You're just gonna use class B and other stuff. So it's getting the setter for the property and updating the new value. Then call recursively. So now I put this there. Save scenes. So now what I do here is trans node. And then I don't need to set the name either. So delete this. So I have to see, so I'm gonna ask how do I get the type. Then what I'm gonna do is put the, so I don't need this, don't need this. Then here I'm gonna add, I did this before, but then I deleted it because I wasn't sure if I was gonna use. In this case, I wouldn't do anything with the tree, I just update the properties because the node already exists. And then if the node doesn't exist, then I add the node to the tree by adding to the parents. The other thing that I'm not really sure is, like, I realize that I don't need to make the nodes as, like, the only node that matters should make it as a, to make the owner as the sing roots, I think is the serializer, but maybe maybe not. Maybe all of them need to be. Maybe this needs to be sing roots. Because I'm not really. I'm gonna ask this to ChatGPT, but I'm not really sure. The owner matters for caching, so I have to set the owner, but I'm not sure if it has to be the sing roots. So I'm gonna ask, but gonna ask that after I ask. How can I compare? Do here. So here, I'm not really sure if I can put. I think I can use the V format that they use. But I'm gonna copy the way that they do the warning messages here. Yeah. It'd be percent as, I think. That should be a const char. So C standard. So if it doesn't work, I'm gonna try to convert this into a static C string. Is and this. I don't creates. So I think this creates a char const char on C, which is the same type that they have there. But I'm gonna try like this first. And here would be. Oh, it makes more sense with the name, not the name of the class. I think that's probably it. And then here, the end, I loop over. So this mem delete, I think, is a function that they created to delete the node from the memory pool that they have. So it calls the constructor of the nodes, the destructor of the node, and then it deletes from the memory. And here is going to choose free after it deletes from the memory pool that they have. So free is the one that is built in from C or C++, I think. I think it's from C that deletes the node using standard library, I think. The built-in. Yeah. So here is on Windows because I'm using Windows now. So it's gonna use malloc probably, or no, malloc is for allocation, but so I think that's pretty much it that I have to do there. So I get the name. Oh, I'm getting the class name here already, so I don't need to get from here. I can do class name here. So I got the class name, then based on this global thing that I keep track here to update the names based on how many types that already exist on the scene, because that way the order doesn't matter that way, as long as the quantity is the same. Is always going to, or maybe the order does matter, actually. Maybe not. I think it doesn't matter because the hash set's gonna have all the names. So it's just to check whether or not the class exists. And it's gonna update on the object based on the objects, so it doesn't matter, I think. Maybe actually it does matter, now that I think about it. Because if I change the order from the code, but the editor version has a previous order, then it's gonna change, it's gonna update the wrong properties, I think. And so this can be a problem. So I think that there's two potential downsides, the order one, and the other one that I talked about, which is checking to see. I am checking now, but like the question is whether or not the. So I'm gonna ask GPT whether this. Yeah, this is the issue here. So this is one of the downsides. So shell comparison, as far as I understand, is whenever you have a dictionary, for example, which is just an object in Python, for example, you would only check for the values on the first level. So if you have a nested dictionary, it doesn't check for the values at deeper levels. The more complex data structures are harder to check because of that, because you're not going to be able to know before runtime how complex it's going to be the structure, because it's going to change it can change on runtime. So usually And this happens a lot on React as well. Because the place that I remember this the most is whenever you have libraries that you use for state management, like stores on React, you're gonna need to do deep comparison. And in order to do that, you usually use a spread operator on different levels of the dictionaries you have when you have nested dictionaries to make sure that the state is updated and takes into consideration all the levels. So ChatGPT is saying that the variant is only going to check for shallow copy. So this is one of the downsides, and the other downside is the thing about the order. So if you change the order in which you add the nodes from the code, it will update the wrong properties because the cached names don't take order into consideration. So because I'm only checking for the number of the values, the names are going to be mixed up, I think. Not really sure if I'm thinking about this the correct way though. So the situation that I'm thinking about is like, let's say I create this scene, for example, like this in the first time. So after you create this scene, then the scene file is going to have cached all these nodes, and the names of the nodes are going to be based on the global variable that I put there, which is a hash map that keeps track of the class type and the integer that keeps track of the amount of class types you have. It's basically this. But then let's say after I do that, for whatever reason, I initialize this object here before this one, for example. Or actually, whenever I have the same type, that's going to be the problem. So let's say I move this object here to initialize on top of this one. Then the names generated from the code are going to have a different number when I call the add child, which means that it's going to check to see if it already exists on the hash map. And then it's going to update here. Or where is the... So it's gonna check here and it's gonna have the name, but and then it's gonna update the property. But on the cached node of the scene is considering that that name for that node is from the old version, which would be this one. So it's gonna end up updating the properties of this node with the properties of this, because I changed the order on code, but the order on the scene doesn't reflect that. So I think the way to solve this is somehow with the name, but I'm not really sure how. Like the name would have to take into consideration the order. Or like the check here, the check has to be... But then how would I do that? Before I create the nodes, I have to check. I'll be right back. I think that there's two things when it comes to the name. Like the main reason why I wanted to do this custom name is so that it's visible, like the difference between the nodes is very easy to see from the editor. But I think like by default, if you don't set the name, the way that they are gonna do it is gonna be based on the class type from the editor. So if you add the node from the editor, it's just gonna make the node name based on the class type. If that class type, if there is a node already with that class type name, you're just gonna add one to the. It's basically like almost the same logic where it's just adding one for each class type that it has there at the end of the name. This is one way that they do it, and the other way I think I've seen on the replace by function on the node. For the nodes that are added as parts of the constructors there inside of the another node, they use another pattern based on the hash, I think. But I think that if I want to make the problem is that there isn't a way I think to solve this that you keep track of the order, because it has to be something intrinsic to the class. And if I make like any because there is no way to differentiate, because the class instance, like the type of the class is always going to be the same. So if I change the order from the code, there's no way to make a value of or something that is a part of the class should always give that thing the same name regardless of which order is added, I think, or which order is initialized, because there's no way for the code to know. There's no way for issuing codes like that. That node is gonna be always the same, because it doesn't make any sense. If you like, the only way that I think the only direction that I can go, but thinking about this is that it would have to be something intrinsic to the class that determines the name of the node. But if it isn't, even if it is intrinsic to the class, there is no way to know, like, to force the order regardless of where you put the thing. That makes sense. The only way that you can keep track is just by which one was initialized first. So the order of initialization of them is the only way to encode the thing. But maybe this is not a problem actually, because if I change the order on code, it should change the state of both. So yeah, I think that it doesn't matter. Because then the other one would update the other, like you would update the wrong node, let's say, but like you would just update the types. So I think it doesn't matter that much. I think it's just a false problem. So the biggest problem is the comparison, I think. So I need to figure out how to do a deep comparison of variants. I'm gonna see if I can compile and run. So if I make this work, then next thing to think about is how to change there. So depending on what kind of what is the type of the property, I do a deep comparison instead of shallow one. So here. That's right. Oh, that should be an address. Software. Let's see, search. I'll push back as well. Gas for gas. Let me. But I think it doesn't matter anyway, because like, so according to what's saying here, it's gonna check whether or not they reference the same place, and it's probably gonna be false, like every time, even if they are the same, because I'm creating one from the node there, and the other one is from the scene, so they're gonna have different pointers. But it's like I said before, where it doesn't matter that much, because even if the tree is very big, I don't think that this is gonna make it extremely slow show updates, and this is not going to be a part of the runtime of the thing. It's just to build this thing. So I think like even if I don't do the comparison and just set the new value each time, it doesn't matter that much. So obviously what I can do is just check, like put some more complex data structure and see if it's going to change, if it's going to update from the code each time. But if I want to do this granular comparison, then I would have to create a different function for each type. And then inside of the function there, I would put a control flow in the middle to check, see what is the type of the variant. And then based on the type, I call the function that compares. So let me see if this works. I made a mistake here. I should probably check for that anyway, but like in my mind, they should always have the same value. Oh, it's because I'm passing the wrong one here. That's why. But I should probably check to see. if they have the same. And so I do. I think there's this way to check. Three properties. I'm gonna put some warning here and then return. Oh, but actually, maybe not. Yeah, I think that's like you can't guarantee that because they have this. They can have the same pointer and be different. I think that's the problem. So again, there's something here. But it's because I'm using the wrong check here. But it's weird because they should be the same. It's kind of hard because I don't know like where exactly this happens. Now let me try to compile and run again, just see if it's gonna throw the warning message. But obviously there's something weird because like it should be the sizes should be the same, I think. So it shouldn't matter that I'm looping over this size here, because this condition shouldn't be true if I have the same class or the same type. The same type should have the same properties. So the size of the list should be the same always, I think. Which means it shouldn't fail on this one as well. Oh, here I'm using get class name. What is the difference? I think I'm gonna use get class on both. That's probably the same thing. Here I'm using get class as well. Oh, I can see here. Forgot I can see the stack trace here. So the problem is that it's trying to access index that doesn't exist here, which is very, very weird. New node. Oh, this is the no. Oh yeah, I should. So the issue is because of the recursion here. Hmm. So I think if I do the same get child for both of them, then you should compare both. But it is a problem because. But if the two nodes that I'm comparing there are the same, then the remaining part of the tree should be the same, I think. Oh, but maybe not actually. It goes back into the same issue that I was talking about later, where there are situations where you're gonna have the mixed tree, where you add nodes from the editor. So the recursion, you would get to a point where the node that I'm adding from the code doesn't have the children that the actual thing has. So the way to solve this is to put a flag variable inside of the node class probably, or I can study the groups, how they do the groups. This is probably more important than this one. Yeah, because I think that the issue is that it's not even that checking only for the editor nodes, is also that like the structure of the trees might be different than the one created from the code. Because I might create the final structure of the tree from different parts of the code as well, and from the editor. So like there's no way to guarantee that if I do the recursion here, if it's gonna stop getting the, like, it's obviously not gonna stop, it's just gonna go all the way until it reaches the end from that node that you're doing the recursion. So that it's impossible to check, I think, for the same structure, because you can have an infinite amount of errors on both trees that you're comparing. And gets to the same problem that I had before. So I think the only way to do it is just by doing without the recursion, I think. Because then, like the biggest issue is the nodes that are added inside of the constructor. That's the thing. So maybe I can create a flag variable and then assign on the nodes that I create inside of the constructor. Maybe that's the solution. Because from the nodes that are added through the code, you don't check, when I'm calling the addChild nodes, I'm not checking them directly. I'm just checking the one that creates them. But they are going to be part of the thing on the main thing. So if I update the properties of this one, it's not going to update the property. And let's say I change the properties inside of the constructor of one of the nodes, it wouldn't update that. So what I have to do is so to do this, they have internal nodes check on some of the functions, but internal nodes, I think that there are different kinds of nodes. And I'm not really sure because I don't think I have seen internal nodes. I don't know how they work really well, but I do know that some functions of the node class they check for internal nodes, so they already have a differentiation like that. So I'm gonna ask ChatGPT as well to see if it has. So I'm gonna comment this out for now. So what I'm thinking about doing is that on the recursion here, so I add a way to differentiate nodes that are created from the constructor and from outside. And then on the recursion, I just put a check to see, like before I do the recursion, I put a check to see if the node is part of the, if the, yeah, the node was constructed, was added inside of the constructor of the class. So if, let's say the flag variable is constructed, let's say, I can check if the node is constructed is true, and if it is, then I recurse for both of them, and if it isn't, then I don't do anything. So it would be here. Constructed. And I think that this should work probably. Because that way I only... Oh, but this doesn't guarantee that, like, the last level is gonna be no, so... I should put puts here as well. But then it's a problem. Because the first one is not gonna be. So maybe... yeah, no, it doesn't work. I'm gonna think about this later. So I need a way to recurse, like to flag a subtree inside of a tree, and then update the subtree. From the roots that is the current node being added. But does it matter? Actually, I think it doesn't matter. Oh no, it doesn't matter because it is different. Actually, maybe not, actually. Yeah, so maybe if I check, I have to check for both of them. I think it doesn't matter because the limit is determined by this one. Yeah, so I think it doesn't matter. I'm just overcomplicating stuff. Because it's gonna stop on the last child of this anyway, so even if this one has more, if this doesn't if this is no, then it's gonna stop. And this is only gonna have the children that are inside of the constructor at the moment that I add this node, because I'm always gonna add before adding other nodes. I think it doesn't matter. I'm just overcomplicating stuff. Because if I check for this one, yeah, I think that the issue that what I was having there is because I wasn't getting the child of the tree node. Like this one is gonna cap the comparison for the subtree that's of the children that it has. So it doesn't matter if the tree node has children that were added from the editor or from other parts of the code. But I should make, like, I'm not really sure if it's gonna be, like, if it's this, I need to see if there's a way to check if they are the same. Because here I'm getting based on the child. So I need to make sure that the order that's both of them, even if there's the same tree, the order is the same. But I think probably what I should do is instead of using this one, I get from the other. So I get the node that I pass here from the tree using this other one. And now I think it's better. So I get, so I can check as well. That's true now. Hmm. I'm not really sure if this would be good, but like I could call, but I think it could cause an infinite loop there. I could call the agile node here, because like this would be a situation where the tree node doesn't have. So let's say I added one more node on the inside of the constructor of this node here, but I didn't update the cache. Then the children of this one would exist, but this one you wouldn't be on the tree because I didn't update. So there wouldn't be this node here. So what I can do is just add this one as well. I'm gonna put both as well. I think I can return here as well. Instead of doing the recursive call. Or maybe just pass. That doesn't make sense, sure. Because if it doesn't exist, I need to check before. I think I can't return because then it's not gonna. But if it doesn't exist, then it's the last one. It should exist actually because it's gonna be. I don't think I need to check this. It's only the other one. Because based on the child count here, so all the indexes are gonna exist for the node. So this one is always gonna exist, and this one is the one that may not exist because the trees are gonna be might be different. So if they are different, yeah, here. So it's probably what I'm gonna do, but then what I'm gonna have to do is just pass the sing root to this function as well. Because then I have to call this one from this one. And I think it doesn't matter that he would create this circular thing because it would always stop on when the node is no. And then it would check for the name again. But then when I call here, it wouldn't go here because it's the same check basically. So like if this failed, then it means that the node doesn't exist, which means that the name doesn't exist on the hash. Which means it would just add to the parent. And the parent would be the current, it would be the tree node. So I would call passing the sing root, the tree node, and then next new node. Now I'm gonna think more about this, just see if I should do this or not. And first I have to see if it's gonna work. I think I'm gonna stop streaming here. Even if it doesn't. I'm gonna think more about this soft stream. If it does work, then I'm not gonna think about this anymore. The only thing I'm gonna change is the thing about the variant, the comparison here. So what I'm thinking about doing is just splitting, like ChatGPT said there, recommends. But then on the case that is a more complex data type, I just set the value and I don't make the check. So I just check for the type. If it is I basically copy here, and if it is a more complex data type, I just set the old value with the new one without checking for deep comparison. And on the basic case, then I check to see if it's equal. And if it isn't, then I update. That's probably what I'm gonna do. I'm gonna run one more time and then I'm gonna stop streaming. That's interesting. How is this possible? I'm also getting name is empty. That's true. So is the problem the name there? So I guess since I changed this, it's probably it fucked it up somehow. So obviously what I can do is just print here. And it's weird that it's also giving this message here. Because how is this possible? Oh no, this is a situation where the tree doesn't have the child. Yeah, but on the good side, it seems that it is not giving any messages for memory leaks, which is good. And it seems that it is running the function, so I think that is probably correct. So all I have to do is figure out. I think these are also the ones that were I was getting the memory leak message. So it's the key of the issue is the nodes that are added on the constructor probably. There's something weird going on that I don't understand very well. And the other thing is this message here of the name is empty. So I think the only place I'm setting the name is here. So I think what is happening is that because I changed here is getting an empty string or like a null value or something like that. So obviously to solve this, I can just go over with the debugger to see exactly what is happening there. I think I'm going to do that upstream. But it's less bad, I think, because this should probably work. So once I figure this out, oh, so what I can do, what I'm gonna do here is also print the name of the new node, because I think I suspect that this is probably the BM spin slider, because on the BM spin slider or on the physics slider, which I use the BM spin slider, it's on the drawing function they add some or they use some resource IDs from canvas item to they're basically manually drawing the shapes using the canvas class that I forgot, render canvas code, something like that. So I think that it is something to do with that class it's probably going wrong here. But what I'm gonna do is just print the name. So new node. Yeah. So what I'm gonna do is just I'm gonna run this. I'm gonna compile, run this again, and then see which node is creating this that I'm adding from code. It's probably gonna be the physics slider, I think, because the physics slider uses BM spin slider, which is the editor spin slider. Oh, there's also this one. It might be because of the ID here. Might be because of that. So I'm gonna see that, and I'm going to go over with the debugger as well to figure out why name is empty is happening here. But I'm gonna stop streaming now. So once I fix this, I think that it is correct there. I don't see a reason. So obviously what I'm gonna do is just test. So like I'm going to create the scene from the code. Then I'm gonna see on the editor like a specific property that I change here. So for example, position, which I know that already works for the first time that you add, is gonna cache the property you put here. And also because of the signal serializer, it does cache the properties on the sync file. So what I'm gonna do is just go from the editor, delete all the nodes, then run once to cache the state that I put here, then open from the editor, see the states, then close. Then I'm gonna change the one value of the one property, compile, and then run again, and then I'm gonna check to see if the properties are the same or not. And if they are not, then I know I can do a bunch of tests basically to see if this check is working. But probably what I'm going to do here is just copy the check that GPT has there. So check for the variant types. If it is the complex type, I just set the value of the new one. And if it is a simple type, then I do this check here, should see. And if they're different, then I set. But if I'm able to do it like this, then instead of removing and adding the node, it's just going to traverse the tree, update all the properties for every time that I change something here. And based on the names, it's never going to add extra nodes that were already added from the code. So I'm going to be able to add nodes from the editor and from code. So if this works, all of this works, then the next step is going to be to build the editor layout from this function here to see how they do the layouts. And probably I'm just going to do different functions for different layouts in the beginning. Then after I do that, then I can start building the applications. So see you next time.